Hello, everyone. It's another Wednesday with your fertility specialist. I'm your host, Ruth Ogugu, for today's session. On behalf of Alps Hospitals, we're saying a big thank you to our dear viewers. Thank you for liking our post. Thank you for sharing. Thank you for always staying glued to your screen. Yes, thank you for always keeping up with updates on various info that we get across to you regularly. Today we'll be talking about CRISPR and fertility. Yes, I'm aware that a lot of people are ready for this topic today, and there's a lot that is something new that people need to be aware of. So, to do CRISPR and fertility today, we have Dr. Buddha, Dr. Kenneth. You're welcome to this session today.
Yeah, thanks.
So, for the sake of someone watching for the first time, a little about Dr. Ken. He's a consultant gynecologist. He's a minimal access surgeon. He's a fertility specialist, an IVF specialist, a very good one at that. Yes, as a matter of fact, he's the one that pioneered laser gynecological surgery in Nigeria and Africa as a whole. And lest I forget, we're talking about CRISPR. It might interest you to know that he's also one of the pioneers of CRISPR in Nigeria. So that's a lot. So you can imagine we have one of the CRISPR pioneers right now talking about CRISPR and fertility. So you know that you are getting first-hand information right now. So please do well to share this link, call up someone so everyone is able to get this information you're about to get. Do well also to drop your questions, your thoughts in the comment section, and we'll definitely attend to them. So as we get started, sit back and enjoy the show. Dr. Ken, it's good to have a CRISPR on here with us.
Let's talk our team.
Yeah, so we're here for CRISPR and
Yeah.
fertility. I'm sure a lot of people are wondering what we're even really referring to as CRISPR. So maybe you should tell us a little about what CRISPR is about before we relate it to fertility.
This is one very important topic.
Mm.
Yeah. So CRISPR, it's actually an acronym. And by the way, from the year 2013 or 14, yeah,
Okay.
you know, when I started getting so crazy about CRISPR and knowing the potential of CRISPR, it's been on my status on
Okay.
my WhatsApp application,
Yeah.
as CRISPR making humans perfect again.
Oh wow. Mm.
Yes, in the sense perfect in the sense of biology.
Mm. Yeah.
Yeah, not perfect in behavior, but perfect in the sense of biology.
Yeah.
So yeah, I've had CRISPR, I've followed CRISPR, and around the world. And I'm glad to see that CRISPR is taking the stage it's taking right now in the world. CRISPR is an acronym that means
Okay.
cluster, regularly interspace, short, palindromic, repeat.
Okay. Wow.
It's the name is coined from the behavior or pattern that characters or proteins are represented on the
Okay.
DNA. They
Oh.
come in codes,
Okay.
and they are repeated at
Mm.
intervals, and so that's how the name is coined,
Oh
came
wow.
about,
Okay.
just to tell that this is how characteristics or proteins or behaviors or traits are
Yeah.
represented on the DNA or whatever you find them in the human genome.
Wow.
So that's how CRISPR came. It's a name that showed how proteins are represented. And a CRISPR itself, it's a gene editing device. You
Okay.
can call it CRISPR-Cas9. It's a
Okay.
gene editing device, that can change the entire course of human nature,
Wow.
yeah, or biological life.
Yeah.
I remember the first lecture I gave about CRISPR in the Department of Science,
Yeah.
University of Jos, in the year 2016.
Okay. Wow.
2016, this was like how
Nine
many
years
years? Nine
ago.
years ago.
Mm.
2016, 2017. Yeah, we talked about CRISPR and the future of biological science. At that point, we're looking at all forms of life because it can find application in animals, in plants, in humans. But I guess today we're talking about in human lives,
Yeah.
in reproduction. And so it's a gene editing device that can change the character or a trait that an individual has to a more befitting trait. This trait could be disease condition, could be looks, could be physique, just anything trait. It could be
Wow.
some hereditary diseases, or it could be longevity,
Wow.
life itself.
Okay.
I
Wow.
mean, living a long life.
Yeah.
So it has a tendency to do all of that for humans. So uh, it works with precision when it's injected into a biological system.
Okay.
It can remove any trait or character you intend for it to remove, and then it can replace it with whatever trait or character you intend for it to be replaced with, And so you want to talk about redesigning humans
Yeah.
or redesigning life.
Can come for CRISPR.
So this is what CRISPR stands for.
Okay, so viewers, I'm sure you are just wondering, is this magic that he's talking about? Well, just I think it was Monday 20th. I think they celebrated
Oh
CRISPR
yeah, 2 days
CRISPR Day.
ago.
Yes, so we felt it was necessary to
Yeah.
talk about it because we've seen some miracles that CRISPR has brought to reality. Like we've heard of cure of sickle cell and all of that. So we felt we should talk about it, and that's why we had to get a special guest to talk about CRISPR because this is more like you're seeing one of them here.
Yeah.
So he we couldn't have gotten a better person to talk about this because he would just tell us everything you need to know. There's so much to learn from this lesson. So I'm encouraging someone to please share this link right now again. Call up someone right now again so they can get all you're about to. And please do not try to leave this chat till we are done because every bit you miss, every bit of it you miss counts. So
Oh
I'm sure
yeah.
you don't want to miss any bit of this session today. Please stay glued to the script till we are done. There's an award for who stays to the end. Well, that's on a lighter note though, but this is just to tell you it's very important that we talk about this and you really do not want to miss any bit of this session today. So yes, please keep staying, please keep hanging in there and a lot more is coming your way. Okay, so how does, because I know you've started talking about the whole CRISPR. I know this is your thing, so if we allow you, we just continue till the end of the
That's
day.
true.
But let's ask a few questions. I know you talked about trying to redesign. How does CRISPR fix and find genes? Like at what level are we at the molecular, what's happening now at the molecular level with all the findings, CRISPR and all what's happening now?
Okay, you see, let me take you back to the year 2000.
Okay.
Then I think Bill Clinton was the president of the United States of America. Then there was a race to understand the human genome. That's the entire genetic makeup of humans. And then different scientists were invited, and the project for understanding the human genome, the race in the United States and some
Yeah.
part of the world commenced.
Yeah.
At the end of that project, by the way, the amount of money spent on that project was the highest I've ever heard on in health, in biological setting like that, close to $200 billion.
Wow, that's a lot.
Yes, yes, yeah, to understand the human genome. And after all of that, they found out that over over 200,000 diseases, were understood from the way
Wow.
the human genome was understood. And then the ability to cure them also genetically became understood. And I remember the statement that was made in the front page of the New York Times, is that today we understood the language
Hmm.
by which God
Hmm.
created man.
Wow.
Because it became clear that everything you understand or see about man is represented in these proteins
Wow.
that make up the human DNA.
Yeah.
And these proteins can be changed.
Hmm.
Yes, can be cut off and replaced with some other desirable protein. The same way all these disease conditions that were understood were
Yeah.
represented by proteins. Proteins can be cut off
Wow.
from the DNA itself, from the constituent of humans, and replaced with some more desirable proteins that will make humans be free of those diseases.
Wow.
And so it was a big breakthrough in the world then, all the scientists involved and all of that.
Yeah.
And today, the person that took the glory, or that took the prize for this innovation, Jennifer Doudna and Emmanuel Charpentier, two females.
Wow.
They won the Nobel Award for Science Breakthrough the year 2020, 2020,
Yes,
between
it was
2020 to 22.
about that time.
So the work of these great women, and today this has set to unravel a whole lot to the world. So what it does is it goes to that place you have abnormalities,
Okay.
cut off abnormality at the molecular level, at the genomic level, and replace it with whatever thing you want.
Wow.
I'll take, you mentioned from your introduction that sickle cell has a cure. Yes, cell now has a cure. Guys have been in the United Kingdom and the United States, and it is CRISPR that is doing it. I know the abnormality in there is that there is just one single protein that became abnormal, replaced by another protein. For those who do biochemistry, it's valine and glutamine, that have this abnormality.
Okay.
Just one alphabet in the protein
Yeah.
abnormal, and then an individual becomes sickle cell disease patient and has this problem till he dies. And of course, Nigeria is the headquarters of sickle cell in the world because we have the highest of sickle cell. But it lies in how the cure for sickle cell is in the United Kingdom and United States, and that is not even mentioned around that. By the way, the government of the day in in England, selects people monthly and cure them sickle cell disease. And our research is an individual cure will cost close to is it 20 or $2.2 million.
That's a lot.
$2.2 million. That's what you have
in
that's what you have the public domain right now. And so you can imagine this is what CRISPR could do. And 2 years ago, or 3 years ago, the major issue dealt in the meeting of CRISPR experts in the world is genetic diseases that was discussed. But it's important or strange to understand that Africans are not even represented in this kind of meeting. So this is the possibility of CRISPR right now, and we'll call it a biological scissors, and it works at molecular level. And it works with precision. It cuts off a trait and replaces it the trait that you desire. So genetics, that's more like a genetic surgery.
Wow. So much for CRISPR, like just a lot. This is more like a working miracle that we really wish that it becomes accessible to all one day. 2.2 million. That's $2.2 million, not just even 2.2 million, because I'm sure a lot of Nigerians will even be able to afford it for just 2.2 million in our naira. But talking of it in dollars, that's a lot. But it's good that we are aware, because first of all, you need to be informed before you know what you want to even go for someone that is considering having a cure on the sickle cell with CRISPR. So that is for the cure for sickle cell. I'm sure there are a lot more that CRISPR can actually offer.
Yes.
So
I'll cut you short at this point. I'm beginning to wake up to CRISPR. It was released just like some months ago
Yeah.
that even babies with Down syndrome
Oh,
were
wow.
also cured using
Ooh,
CRISPR.
okay.
Kids with Huntington's disease, these are diseases that have no cure,
Yeah.
were also
Hmm.
cured using CRISPR in the public domain. Okay.
Wow.
Before now, we know when you have Down syndrome, which is an abnormality that comes when give birth to children,
Children.
you could have Down syndrome, for Down syndrome. And Down syndrome comes with all kinds of abnormalities, mental, uh, let me see, brain abnormality, heart
Yes.
abnormality,
Hello.
and skeletal abnormality, and
Yes.
all of that. But now to hear that CRISPR cures it makes
Yeah.
us so cool that
Yeah.
this CRISPR that I've refused to pay attention to
So
is
yes,
bringing
it's
cure
making
to
waves.
a lot of impossible diseases, genetic abnormality in the world.
Wow. So no matter how you feel, it's not easy to come by. As long as it's existing, it means that somehow it will become available and accessible to people. It's just by the corner. I'm sure over time, gradually, it will get available and accessible. So maybe we should talk about it in relation to fertility. What are the possibilities of CRISPR with fertility, with embryos, with PGT, and what do people stand to gain in existence?
You know, before the world actually sanctifies the human genome.
Hmm.
Like nothing should touch this human genome. Like there's
Nature.
something
Want to preserve
exactly
nature.
want to preserve nature. Like there's something very good about the nature. you know, until not too many years ago,
Hmm.
in China, yes, I'm mentioning China for good now.
Hmm.
In China, you have a couple who were both HIV positive, desiring to have babies, and then wishing that they could have babies without infecting HIVs.
HIV.
Because one of the risks of parents having HIV is the maternal to child transmission of
Yes.
HIV by one way or the other.
Other.
So they had a discussion with this reproductive scientist,
Okay.
you know, and so they decided to go for an IVF because IVF modalities of trying to avoid HIV.
Yeah.
When couples have HIV. So
Yes.
so embryos were generated for them.
Okay.
I mean, they
Okay.
did IVF.
Yeah.
Embryos were generated for them,
Hmm.
and in the embryo, at the embryonic stage,
Oh.
CRISPR was injected into the embryos. But this CRISPR was designed to tinker the CD4 cells. See, the HIV virus
Yeah.
attaches to the CD4 receptors.
Oh.
So the
Okay.
CD4 receptors were modified using CRISPR at the
Hmm.
embryonic stage.
Stage. Wow.
That's before
Hmm.
real life starts.
Wow. Wow.
You know, the CD4 cell receptors were modified. Now, these babies have received through IVF, have
Hmm.
been born because the CD4 cell receptors were altered.
Yeah.
HIV virus lost the capacity
Oh,
to
wow.
attach to them and infect these babies with HIV.
Wow.
Today, they are
So for
grown,
life,
they are
they're
in this world, they
wow.
cannot be infected
Infected.
with
Hmm.
HIV virus.
They're
But when
immune
this, when this
already.
happened, it code of human genome in China,
Hmm.
because the ethics is that don't the human
You
genome.
know.
So this scientist was imprisoned
Oh
for
no.
3 years. But this
Hmm.
happened actually left one of the CRISPR meetings, because
Oh.
yearly there is an annual CRISPR meeting,
Meeting. Okay.
every October.
Oh wow.
You know,
Hmm.
and so when the world sat and looked at this,
Yeah.
they saw that how would you judge this? These
Hmm.
babies have been powered not
Yes.
to be infected with HIV, even when they accidentally consume HIV
HIV.
virus itself.
Wow. Wow.
I know. So it looked at it in a reverse way,
Okay.
and now they decide to honor this man
Oh,
with a
that's
release
sweet.
from prison, an
Hmm.
award for doing breakthrough in
True.
reproductive
Yes.
medicine.
Yes.
So
Exactly.
he is alive now, and he
Hmm.
is one of the voices for CRISPR, not just
CRISPR.
in China, world. So it's like like the savior.
Yeah, he is.
And so this is what it can do to the embryos.
Wow.
This is what it can do to reproduction. In his own case, it was ability not to be infected with HIV, but there is a lot done. Diseases like cystic fibrosis, for instance, that has no cure and it's practically like a life sentence, could be taken care of from the roots, from the human genome with CRISPR. Down syndrome, we said, have been done already. Other muscular disease conditions can be tackled. Sickle cell can be tackled at different levels, at embryonic state, with pre-implantation genetic diagnosis, CRISPR, even when CRISPR can be applied to you as an individual and it to cure of sickle cell disease. So there is a lot. And then we have a lot of the conditions that we inherit. And every kind we manifest is in our genome, in our gene. CRISPR take it all out. Wow. So if you ask me, I actually see that that life hasn't started yet. We're just into the era where real life will start.
Rebranding.
And then we have humans that have been empowered one way or the other badly to face the challenges that this.
Wow. CRISPR. Okay, so now you were talking about all this. All I was thinking of was aging. Nobody wants to go old.
Yeah.
So maybe we should talk a bit about CRISPR and aging, because I know that I think at some point you've said a little about how CRISPR could help with dealing with some of the gene. And I think everybody has the potential to get old one the other. So is CRISPR actually applicable to aging? Like, does it have any impact if applied?
So we know what makes people age. People start getting older or age accelerated aging when the tail of the DNA starts to get short. The tail of the DNA, we'll call it the telomeres. If you understand, if you look at the structure of DNA, you have the part you call the tail, the telomere, that has a cap. So tail shortens quickly. You get aged quickly. And age-related disease attack you quickly. And probably you also die quickly. So with CRISPR, all of these things, and there are habits that shortens the tail of the DNA very fast, the telomeres quickly. And if anything you do to shorten how to reduce how quick the tail of the DNA shortens, actually prolong naturally the human life. So with CRISPR you can actually make that happen. To delay the shortening of the tail of the DNA and all of that. So humans can have a capacity to live for a very long time.
Wow.
And of course, science of aging is already established to perfection in the world.
Wow.
And I think all that is being awaited is the political will and the ethics of the world to decide how applicable this should be. Maybe who should access it, who not to
access it,
and all of that. Because whether we like it or not, the world is looking at how not to age. Because the last meeting that the guys controlling the BRICS nations had, in China, you had President Putin and Xi Jinping and Modi of talking about wanting to live for a very long time. So it means the world leaders are already thinking about it. And these are actually leaders of frontiers. The science is there. The science is there. And with CRISPR, you can actually generate human organ in other animals.
Wow.
Yes, you could, knowing the code that forms the of humans, you could replace it in the genetic of a pig, for instance.
Wow.
And the pig grows the kidneys or liver organ. So when you people are getting old naturally, because kidney fails, other things fail, you could transplant it without having problems with acceptance of transplant grafts.
Wow. Wow. So that's a lot. This is a very, very huge, complex technology that seems to be far away, but we hope that it gets really close to us. With all that you people are doing now in CRISPR, do you think it will get to a point where like people are taking immunizations, common as immunization, do you think we would ever get to that point?
Okay, you see now, the truth is these are areas that the world has to sit and decide how it's going to go, because now every character you see in a human being
Yes.
is protein represented in the DNA of that person, and that protein can be changed. Intelligence can be genetic and environmental.
Yeah.
So the gene for intelligence can be changed.
Oh, wow.
Yes. So you could decide how intelligent you want this individual to be. It is one of those characteristics. There is a book called CRISPR, the Apocalypse.
Okay.
It's a book that is like a prediction of how the world is going to be in future. And among the characters that the world may eventually edit, that is intelligent quotient, IQ, beauty, strength, endurance, and I think the fifth is workaholic gene. Everything you see is controlled by a gene. And what is the importance of the gene of beauty?
I'm sure the women will come for this.
Yes, there's a gene controlling beauty. What's the importance of gene for beauty, for instance? Beauty is important. Ask guys. Just ask guys what the importance of beauty is. It's important because you see, when you are a pageant, for instance, it's as you are beautiful. You have access to a whole lot of things, and you are able to have international bring world attention to your region where you live and all of that. And that is all we are looking for. Be a spotlight in the world for good, And pageants have, for instance, roles that they play in society. They draw attention to the society, and because of that, they do a lot of charity work and all of that, and it helps humanity. So beauty is okay. Then gene forms and workaholic and all of that. I'm tired of seeing lazy people. You understand?
Lazy.
So when you have all of these, we call it the big five. Actually, it's called the big five.
Okay.
So these are the genes. So they make in the form of immunization. Yes.
Wow.
So that every child has a capacity to get this form of immunization. In case it may be universal. Can be universal. So do immunization like you're taking tetanus vaccine, polio vaccine, rubella, German measles, and pertussis and all of that. These are,
exactly.
But we're looking at the future where even immunization will be genetically, to enhance. And for intelligence, for instance, so you can change the intelligence of a child up to the age of 13 at the moment.
Wow.
A child can get the vaccine for intelligence up to the point
13 years. Wow.
And who doesn't want intelligence? You may see it like a mundane thing, but intelligence means you're able to invent, develop things, create things, and think out of the box. That's intelligence. The more intelligent people you have, for instance, the more national development, GDP, and all of that you're going to have. So it is a political, let me say, heuristics. If a government has it properly, they are going to go far in doing development. I think the world should be ready for what is coming, because this is where we.
So when you were talking about beauty, I remember the parts of the holy book that says there was somebody that was described as beautiful and fair to look. So I'm sure if they have to do a queue of people that will come for the fight, maybe you have the highest queue of people coming for beauty.
Yeah, that's true, because
and then intelligence is really attractive. It's something that attracts people anytime.
Exactly.
Yes.
Exactly, because you come from school and then you say you've done your lesson. They ask you is what grades do you have?
Exactly.
Hey, you say, hey dad, I have all 5 Tell me, your dad is definitely going to.
That's true.
Then the guys that has F9s, failed all through courses, the parents are also going to be sad.
That's true.
And this intelligence is celebrated everywhere. And then look at it. When it comes for scholarship, to give scholarship, they give scholarship to those who perform better than others. So whether we like it or not, intelligence is an international trait.
Yes.
And it is going to be heightened. So that it's going to be a competitive trait.
That's true.
So that is headed.
So please, people should.
So let me even tell you something. If you look at ladies, for instance, a good number of ladies have double eyelash. I don't know what it's called. Is it masquerade?
No, mascara what they apply on the eyelash to make it longer, but they do the extra eyelash.
Okay, extra eyelash. So about I really don't know.
Or the eye fixing.
So now there is a gene that controls eyelash.
Okay. Ladies, bring your chairs closer.
So if a lady has a gene editing of the eyelash, for instance, so she could grow double eyelash, and she doesn't attach an extra eyelash. That's one. And for guys, there are genes that controls muscle building. Every guy wants to be a hunk. Every guy to be a hunk. Those who are not, because they've not worked hard enough, or because they don't have the capacity. Well, I'm not. We have a gene we call myostatin genes.
Okay.
When the gene is activated, you grow muscles.
Okay.
Like King Kong. And then you can
walk
with your bare chest, chest, and ladies like you. So that's it. So every of those things are controlled by genes. So you get to a point that a parent wants to have a child. One thing I know, I've been in reproduction for a while. When parents give birth to beautiful children, I know it.
Oh goodness!
That this child is beautiful.
Beautiful. That's true.
This child is beautiful. So naturally, they like it. If you tell them, let's make your child beautiful, you God. By the way, God is not in this business. It is human endowment, human choices that make people look the way they are.
Yeah.
Get married to me, I probably look like us. They can't look like someone else.
Yeah,
so where is God in it? It's the choices that people make that give them the genetic lottery they have and genetic expressions they have. And most of the genetic expressions are product of mutations and accidents. You're not changing what God did. You're rather changing and improving what humans have done. A short child, for instance, is not by God. It's made short by the genes he inherited from hence.
That's true.
So people get to the point where they exonerate the deity.
That's how God wants it.
God doesn't want that. God doesn't want short. That is how people feel that when they have sickle cell disease, for instance, they say God. It's an annoying thing to say. And I'm sure God is angry with that because I'm a Christian and I'm a proud one for that matter. Every good gift and perfect gift comes from the Father of light.
Yes.
And there is no shadow of turning or variability.
Preach on.
Things are bad. Don't attribute it to God. They come from you, not from God. So if they are to be corrected, doing God's work, so that is how much we understand reproduction, and so those traits have to be changed. You can give a lady double eyebrow if that makes her happy. You can give a guy good muscles when you modify his myostatin genes. Even the blue eyes, for instance, the blue eyes walk into of entertainment, for instance. Everybody wants to enter, and people will practically be piercing into our eyes, try to see. Is it the contacts?
Yeah.
Cultural? How get these eyes. But by the way, this eye thing started as a mutation that happened some 1,000 years ago. It started from a fish who got mutated gene that controls the color of the eyes. It was a mutation, but became a celebrated mutation. And today people will pay whatever they want to pay blue eyes, And then we have other shades. There are even green, there are white, there are all of that. And choose what you want.
So CRISPR, wonders of CRISPR. You think, yes, this is, yes, you're one of the pioneers. Do you think there are some barriers to the advancement of CRISPR, or to the availability of CRISPR, or to its advance generally, universally, globally? Are there some barriers, or are there some ethical considerations in relation
By
to?
the way, yeah, I will answer the question in a bit. You see, sometimes you wonder, there are a lot of diseases that have no cure. One, hypertension is another.
Sure.
Aging also is a case you don't know. But we're looking at the possibility of classifying age as a disease by the year 20. Aging will be classified as a disease, and then people have the option to age or not to age. That's left for them to accept whether they want it. For me, whatever makes you stand out, go for it. Now, this genetic treatment is not vaccine. When you say aging is a disease, for instance, it is really a disease. There's no old person that is healthy. Your eyes are not seeing properly. You can't chew. Your teeth. You have itis. Then you have diabetes. Then all these things are represented in the human genes. And they get activated when you get to those age. With CRISPR, you can take out all of them. So tell me, what's not good about it? You can take out the gene for diabetes. My mom is diabetic right now. I know what that means. I'm actually worried for myself because I'm the genetic lottery from her. So you could take out all of those genes, and then humans will be perfect. So you can see what I said in my DP, CRISPR, making humans again. Imagine a world without diabetes, a world without hypertension, a world without arthritis, a world without genetic disease. That world is possible. And it's only possible with gene editing. Even human life can be formed now with gene editing. I feel before you end, scientists from Cambridge University just 4 to 6 ago made a publication. It was on BBC in case anyone wants to go search. They understood every part of the genomes, and they said they can form life from the laboratory. Ask me how. That's the power of science. That's where we are. Now, you ask a question, I'm beginning to forget.
And possible ethical consideration in relation to CRISPR. What things that you think might be barriers to its advancement, or even its availability, people generally?
Yes, one of the barriers is knowledge. In 2017, when I made my first lecture on CRISPR in University of Jos, Department of, we even got some kids that were placed on scholarship, after the lectures. The knowledge wasn't there. So all the lecture was like speaking, above people. Then 2018, when we have the the medical still in the University of Jos, we got people interested. Now, people are not aware of all of these things. That is one major barrier. Government needs to make policies. When AI became very prominent, before the G7 nation and the Europeans had their meeting, form ethics and codes deploying and using of AI. So I also would think that there should be a world summit on gene editing, so that there should be control on what should or shouldn't be done with gene editing. So those are some of the things I think. When all of this is done, and of course the knowledge we spread further and far, and then maybe science department, various institutions can key into it. Actually actually product of CRISPR that you can just buy from the shop and use to want to edit
Wow.
in places where this exists.
So that-
You know, but then just so wide.
wide.
Africa,
Yes.
Europe, America, the gap is practically an invention from America.
Wow, that's wow. So a lot about CRISPR. Viewers, I know that a lot now are dazed, and a lot of you are just like, we really wish this would be available, this would be accessible. Well, we hope someday it gets reach of this gap is being knowledgeable, and then from there we see how we try. So as we wrap up this session on CRISPR and fertility, what's your maybe you should just give us a little brief up of your concept about CRISPR and what stands together generally.
Well, I think my counsel will actually be to those.
Okay.
Yeah, because I change in the near future. Already we are in the era where AI is dominating a whole lot of things.
Yeah.
But it's going to be more interesting when you have the combination of gene coding and artificial intelligence ruling the world. So it should be made popular in the colleges around the world. And this is going to be a different kind of surgery, molecular surgery, genetic surgery with precision. Yes, size genetic surgery, cutting off what you want to cut off and reunite. That's going to be the future of medicine. And when you have all of this in place, a lot of this disease manifestation right now will not be there. And so medicine will take a different body, a different form. And that is actually, for me, the beginning of life.
So could share this link with them, so they are also getting, and so we're able to spread this across a lot of people. And so we see where that takes us to, and we hope that someday, not so long from now, it's accessible to Africa, Nigeria, and
it could cure cancer. Cancer has genetic abnormalities to a large extent. Okay. They happen where mutations happen, and then you have excessive growth of autonomous growth of tissue. A good number of the cancers are in our genes. So you could do a gene profiling, a genomic profiling of find out they're going to have cancer in later life, that gene, and replace it with a healthy gene, and they won't have cancer. So it's just so much we can't exhaust it in one day. So that is where medicine is right now.
That's a major move in medicine. That's something that is really hitting hard on a lot of people. It's so common. So we hope that somehow some people are able to get cure from this, and it prevents them from coming down with cancer. It's been amazing. Well, yes, even though 20 years has passed, but we want to still say happy World
CRISPR
Day. Yes, so happy World CRISPR Day to every CRISPR personnel out there. Every CRISPR person, we celebrate CRISPR, and that we hope it becomes available to the masses very, very soon, and very, very soon at a very affordable price. Yes, dear viewers, thank you so much for staying tuned with us. It's good to have you guys engage us this afternoon, getting into evening. Thank you. Please continue to stay tuned as we bring more interesting episodes your way. Please, just in case you have you still want to talk more with the doctor, or you want to have a consultation with any of the doctors or nurses you would want to communicate with at ALPS, you could book an online through the number being on the screen, and you will definitely be attended to. Well, just maybe a phone call away or a text message, you definitely be attended. So look forward to getting that from you, or that message from you. Thank you, dear viewers. Until coming next time, have a lovely evening.
Bye.